All right. Hey, everyone. Welcome to another episode of Deep Dives. This time we are going to be doing Uniswap. And to help me do Uniswap, I have Torgin. Torgin, welcome. So Uniswap, I actually reached out to the Uniswap team. I couldn't get anybody from the team to agree to do it. They kind of just ignored me. So I know that I was actually reaching out to Torgin about doing a Chainlink one, but he said he knew the Uniswap one's actually a lot better. So how are you involved in the space, Torgin? How do you know Uniswap oracles?
Yeah. So currently right now I'm working as an auditor with chain security. But before that, when I was studying, I wrote my bachelor's thesis about the Uniswap oracle and how to manipulate it. And then I turned that into a paper later, which I published a couple of months ago. So yeah, that's basically why I dove really deep into it. I wanted to make it basically a comparison between Chainlink and Uniswap oracles, but it was just way too hard to actually find good information on Chainlink. Like it's super intransparent, like what the individual like Chainlink node operators, I guess, actually do to get their data. So yeah, then I kind of just pivoted to Uniswap because there you can actually understand exactly what's happening because everything is public and open source code.
Well, it's actually Uniswap oracles even in general too. Like they, for how open source and it is, there's not a whole lot of actual just documentation and articles on them. You kind of have to be pretty technical to kind of get in the weeds of the Uniswap oracles. It's not. I would say part of it's because like they don't really go around and market their oracles, I guess you could say.
Right.
Yeah, so like as far as Uniswap oracles go, like there are a lot of notable projects using them, and there have been kind of attacks in the past. Anything. I guess you've sort of analyzed them versus other oracles a little bit, but I guess how has your kind of thinking about oracles in general changed as you've been walking through looking at Uniswap oracles versus off-chain oracles? What do you think is the future, I guess you could say?
Well, I mean, I think honestly, my ideal future is one with as few oracles as possible. Like oracles are just hard to do. Unfortunately, there's a lot of cool stuff that you can do if you have a good oracle. But yeah, basically it's like any oracles that have off-chain components are never going to have like the same security as Ethereum, let's say, right? You're always going to have like some extra trust assumptions there. And like maybe you can minimize those, maybe you can use some fancy cryptography signatures, whatever, to make it better. But basically it's just the off-chain world is untrusted and anything can happen. So that makes it hard. And that's kind of what makes the Uniswap oracle super cool, because the Uniswap oracle has no off-chain components, right? Everything happens on-chain and it's just a smart contract. The Ethereum network guarantees that it gets executed exactly the way that it's written. So yeah, that's what makes it cool. That's what makes it require no trust assumptions. And then the question is kind of, do the semantics of the oracle actually provide what you want, right?
Which I think we can get into a little bit, but
yeah, for sure. But basically, like people that use oracles usually have like expectations of what the thing that the oracle provides is, which is not exactly the thing that it's specified to be, right?
Right.
So like if my specification of the oracle is just I report the price on some specific market, but that market is manipulated, then even though the oracle worked correctly, the person that is using the oracle probably assumes that the oracle is reporting the price of the asset and not the price of the asset on that specific market. That would be like an example.
Right. Yeah. Well, I guess we can just kind of jump right in then. I'm going to switch over to speaker view here. But before we kind of start talking oracles in general, do you want to give a Uniswap 101 for any listeners that may be, not quite familiar with AMMs?
Yeah, sure. I mean, I'd say probably we want to do Uniswap v2, right? It's like the simplest. Yeah. So basically the idea is that Uniswap is a decentralized exchange where you can swap two tokens for each other and do that fully on chain without having to trust any central authority like Coinbase, for example, to hold your tokens for you. And the way that that's done is, as you've nicely drawn here, you have basically a pool with two tokens in it. And the idea is that if you put one of the tokens in, you get the other one out, and vice versa. And then in that way, you can trade one token for the other. And the way that the pricing works is that basically by definition, both of these token pools are worth the same amount. And the price that the assets have are just the amounts divided by each other. So maybe we want to make an example of that. So let's say if we had...
You could say this is ETH and this is USDC, for instance.
Yeah, exactly. So then let's say maybe there's 10 ETH in the pool and there's, I don't know, 20,000 USDC on the other side.
So side one, side two, and then so you have what, 2,000, 20,000?
20,000.
Yeah, 20K. So then this would imply price of, what's that? 2,000 ETH, $2,000.
Exactly.
2,000.
And that's just those two amounts divided by each other.
Yep.
Because we're
yeah.
Exactly. And because we're saying that both sides are worth the same amount by definition, then this is how the price needs to be for that to be true. Yeah, and this doesn't necessarily mean that the price of ETH on any other market is $2,000 as well, right? Right. It's just on this specific market.
So then the way it would change is the person would come in here, they would say they want to trade 1 ETH for 2,000 USDC, they would deposit this to up to 11 ETH, and then this would come down to 18,000, or we're just simplifying here for math. Obviously, it would be a little bit different. And then what's the implied price here? Somebody with a calculator in the office? But either way, it's much more. So who's doing it? Sally?
I don't know.
18,000 divided by 11. Who can do it in their head?
It's 1,630. 1,630.
1,630. There we go. Perfect. So as you can see, you put ETH in, and now the price went down. And so this is, I guess, a nice example. And now, if the price was actually closer to 2,000, it sort of incentivizes people to come in here, and now you can buy up ETH and rebalance the pools, right?
So, and also basically what we did is sell ETH, and then the price of ETH went down, which makes sense, right? That's what you want in a market.
Yeah. And then this is the important piece, I guess, for us, because this is what the Oracle is, right? It's just.
Exactly, yeah. So, and basically this is what people did back in Uniswap v1 days, which worked basically the same, is people just took the price of Uniswap, of a Uniswap pool, and said, well, that's the price of the asset, right? So that was like the most naive possible Uniswap Oracle. Yeah, shall we go into why that doesn't work?
Sure. Yeah. So this is V1 Oracle. is just the price. You just read the price off of a pool, and that's it. So, but please, Torgin, tell us why this doesn't work.
Exactly. So basically, the reason is that anyone can manipulate this oracle very easily by doing exactly what we just showed, just trading on Uniswap, right? So what I could do, for example, if let's say the true price of ETH was $2,000, but I wanted to manipulate it to be 1,630 as it is here, then what I could do is sell 1 ETH and then trigger the Oracle update, right? There's probably some function somewhere that you can call, which triggers the Oracle. And then the Oracle checks, oh, okay, the price is 1,630. And then that's what it returns. And then afterwards, I can just buy back my 1 ETH and return the pool to its initial state. And then I basically had 0 costs, right? It didn't cost me anything. I get back the 1 ETH that I sold. But the Oracle gave me a price that was incorrect. And what's even worse is I can do all of this within 1 transaction, right? I basically sandwich the Oracle update between 2 trades. And I can even do that with a flash loan. So I don't even need any money to do it.
Yeah, so this is the idea of, you could do this all in 1 transaction. You could have the Oracle update sort of go right in the middle here. And now you just manipulated the pool to show that the price is actually way lower. And obviously people in the past have even done this to where they'll completely drain the pool. They'll make this look like it's 0, because like, why not? It's a flash loan, or really close to 0, or you can make it really, really high. And then it's a really bad Oracle. But this is, and I mean, this is sort of an attack on, you know, a Uniswap Oracle, but this exists in traditional financial markets as well. Like you could, like in the futures market, like there, for instance, there's like, it's called like banging the close, you know, where you can actually just, you manipulate the spot price so where you can make gains in a futures market. And it was always a big problem. And it's, unfortunately, it's illegal in the real world, but it's not sort of enforced here in Uniswap land.
Right.
So cool. Any other issues I guess you can see with just the V1? I mean, I think price manipulation is just probably the big reason. Just don't ever do this, right?
Yeah, exactly.
Yeah.
And there have been like hacks that did exactly this, right? In the beginning of DeFi summer, there were many protocols that used this as Oracle. And I mean, I don't know the exact numbers, but I'm pretty sure there's multiple millions of dollars that were lost due to this simple thing that we were just able to explain within 5 minutes. So yeah, I guess the question is, what can be improved on this?
So what can be improved, Torgin? How did
Yes.
they think about it, and what did they do to sort of fix this?
Right. So I guess this is where we introduced the Uniswap v2 Oracle, and it works basically the same way. But there's 2 important differences. So the first one is that you can no longer call the Oracle update in the middle of a block. The way it works is that at the beginning of every block, the very first time that a Uniswap pool is interacted with, or like a specific pair, it records the price before the first transaction happens. So basically, this is the price after the last transaction in the block before, and before the transaction in this block. And it's like the in between the blocks, kind of the price. And what that means is, first of all, you can't do this sandwiching, which I described. And instead, if you wanted to manipulate it, you have to manipulate it at the end of a block and then kind of leave the market in a manipulated state over the edge of the block, which means that basically anyone can see that the market is in a lopsided state, and that there's an arbitrage opportunity.
So like in
So
this case, this would have to be separated up into 2 blocks.
yes,
So you could still, you would have to finish this block and then go call it, but before that, you could potentially get front run and somebody could update the Oracle or update the pool and buy ETH for 1,600.
exactly. So the Oracle update would still happen the same way, right? The price would still be there, but you would just lose a lot of money, or like potentially a lot of money, right? Because someone else is going to take this arbitrage opportunity of buying ETH at this low price of $1,600, and basically any profit that they make is coming directly out of your pocket.
Yep. So you would have to make sure that basically the amount you're making on the Oracle update is worth it to you.
Yes, exactly. And now this is where the second part comes in. So in Uniswap v2, usually you don't just use a single block's price, but instead you use what we call a TWAP, or time-weighted average price. And basically what that means is just you take the average price over some period of time. Typically people use half an hour, which is about 135 blocks. And you just take the average price. You record, you kind of record the price in every block. In practice, you do it a little bit differently. And then you average out over that. And then that means that if just one of those blocks is manipulated, then the effect of that on the total Oracle price is a lot smaller than if you just take that one single block's price.
So then, so like we'll do this example. So like now let's come down. We can do what would be 9 ETH, and then let's do this one up to 22K. Now what's the price? Somebody have got. So I'm guessing it's like 21,630 or something like that.
It's 2440.
Oh, 20.
Let's just say 24.
Oh yeah, geez. 2,400, something like that. Yes. And then
this is all rounded.
Yeah, it usually works on a curve. So we're just, so then for the TWAP, you would say like, so if this, you would take a record of each of these if they were all at separate blocks, and then you would take the average on behalf of the TWAP.
Yeah, exactly. So let's say that all these transactions, or let's put the first 2 transactions in the first block and then the second 2 transactions in the second block.
One block. Okay.
Right. And then if we took a TWAP over with a size of 2 here,
Okay.
then we would take a look at the last price in the first block, which is 1630,
Okay.
and then the last price in the second block, and we would add those 2 up and divide by 2.
So you
because
ignore the
our length
first
is
2
2.
prices. I guess this is because of this, the first piece up here.
Yes, exactly.
Okay. Cool. And then I guess the question would come in. So how does it do time? I know the blockchain doesn't really handle time so well. Does it just assume that 135 blocks is equal to 30 minutes?
Right. You just specify it as a number of blocks, and the time doesn't actually matter. So it wouldn't actually be a 30-minute TWAP. It would be like a, let's say, 135 block TWAP. And I guess maybe something that is relevant is you don't actually save the price at every single block, but instead what happens is the Uniswap contract has what they call an accumulator, and that just saves the sum of all the prices that have ever happened.
Over a certain period of time, right? Or forever?
Just forever, since the pool was created. So if we're at a certain time and we want to start our TWAP now, what we do is record the value of the accumulator right now, and then we record it again at the last moment that we want, and then we subtract those 2, and then we know what the difference was within our TWAP period, and then we can divide that by the number of blocks, because it'll like sum it up, it'll count it once per block,
So like
And then if we do that, we know what the average price over the TWAP period was.
So let's say we have a 3-block TWAP we want to do for sake.
Sure.
So like if we start the pool up here, and then we have a price of 10, 15, 20, 25, 30, 35. We would just, the accumulator would keep the sum of all of these.
Right. So if this was the, I mean, are you writing down the prices
Yeah,
or
so
the
these are
accumulator
prices.
values?
If I'm doing
Okay.
like prices here, and we
Right.
have a 3-block TWAP, how would this work?
Yeah. So we would start, or what the accumulator does is it just sums those up, right? So maybe you want to write that in the column next to it. It's
135.
10 and then 25 and so on.
Yeah, so 35 is our sum total. But then,
Right, but you do it every block, right? You keep updating it.
oh, so it would be like 10. So accumulator would be over here. So it would be like 10, 25, 45, 70, 100, 135, like that. Okay.
Yes, exactly. And so now if we want to take our TWAP period, let's say starting at the second point when it's 15,
okay,
then we take a snapshot of the accumulator at that time, right, which is the 25,
right.
and we have to save that somewhere ourselves, right?
So you would say in your smart contract, this is how, if you're a user.
Yes,
so
exactly. I would save that in my smart contract.
Smart contract. So he puts that over there,
and then we wait however many blocks we want,
one,
right? So if we have 3 blocks, you wait 3 times.
okay, and then you put that over there.
Yeah, exactly.
So then you
and
sorry.
yeah, so now we subtract those two, right? So 100 minus 25.
75, and then you divide by the 3 blocks, right?
Yes, exactly.
Okay.
And then that tells us that our average price is 25, which let's see if we made it off by 1 error or if that's about right. Yeah, that looks right.
Yeah,
Perfect.
cool.
Yeah,
Oh.
so that's how it works. Yeah.
Very cool. Well, I know that, I guess sometimes people have said like Uniswap time doesn't follow real time in certain periods. So like whenever, like whenever the market broke down and you had like 50% drops in one day, it looked, the 30-minute average was a lot faster than 30 minutes actually was. And I think it was because the block time sped up maybe.
Yeah, so if the Ethereum hash rate increases and blocks get produced at a faster rate, then you would have more of these, and then your TWAP would be over a shorter amount of time.
Yep.
In proof of work. Whereas after the merge, which is going to happen pretty soon, right? There, the block times are always fixed to 12 seconds.
Yep.
The only thing that could happen, I guess, is that blocks get skipped in proof of stake.
So cool.
Yeah.
Do you think that would give any issues for a V2 Oracle user, or probably not?
Probably not, but there's a lot of other issues.
Other issues like such as, come on, please.
Right. So I guess now we get kind of into what my paper was about.
Yep.
So if we take a look at this TWAP and we think about how are we going to manipulate it, the naive approach is that we just start at the beginning of the TWAP, and then in every single block we increase the price to whatever we want it to be, right? So I mean, here in your example, the price is actually increasing, like
right,
the true market price, but typically prices don't move a lot, right? So maybe we want to make another example. Sure. Where, like, let's just say the price starts at 1 to make it as simple as possible.
Or erasing some of these. So, okay, so the price starts at 1.
Right.
And then the aggregator over here, accumulator.
And we're going to say that the actual price of this asset is also 1, right? So like if you look at Binance or whatever, any other markets,
and then actual price, right?
there it trades at 1 and it will continue to trade at 1 for this example.
Okay, so okay.
And now our goal is that we want to manipulate the oracle to a price of 2, right? To just double it, even though that's not the true price. And so what we do is we just buy that asset on Uniswap until the price is 2.
So
and then
go slowly over blocks, or would you want to just do it all at once?
You just do it all at once in the first block. You just move the price to B2, right? And you do this at the end of the block, and then you have to wait until the next block so that it gets recorded, right?
Okay. So then you would have a recording, you would do another trade at 2, or does that not matter?
You don't necessarily need to do that. If there's no trade in a block, then the Uniswap Oracle also just records it as the same price. But what will probably happen is that an arbitrager is going to see that the price is wrong, right? They can sell this token for 2, even though it's only worth 1. So what they're going to do is they're going to trade at the beginning of the next block and reduce the price back to 1. And now what you want to do is kind of back run this guy. So after that transaction, you want to buy the asset again so that it's 2.
In the same block?
Right? In the same block. And so then at the end of the block, it's going to be 2 again.
We'll separate
right?
up by blocks too. Yeah.
And that we basically just repeat this as many times as the TWAP length, right? We always rebuy and always bring it back to 2.
Now we have a TWAP of 2.
Yes, exactly. And so basically now our average price is going to be 2, right? And that's exactly what we want.
Cost to do this for him.
The cost is going to be whatever the arbitrage loss is.
So he was $1 per block here, if you're assuming 1.
Well, not really, right? Because the Uniswap price function is not a straight line. So,
yeah, sure.
So the amount that you lose is actually dependent on the liquidity in the pool. Right. So if the pool is larger, it takes more money to move the price from 1 to 2. And yeah, so the amount of money you lose is dependent on that. And there's like a super nice function or a super nice formula for that from a paper by Guillermo Angeres and Torgin Mackinga, which they basically just calculated how much that is. And yeah, so now we've achieved our goal, right, of having this average of 2, and we've paid like some amount, which is whatever the arbitrage profit was. And this is basically what that paper, which I just referred to, said was the cost of attacking a Uniswap v2 Oracle, is just arbitraging, or the cost of arbitrage in every single block. But it turns out that that is actually not the cheapest way to attack this. And this is what I showed in my paper. So now let's imagine that instead of just manipulating the price in every block, what we do instead is we manipulate the price in one single block to a really high amount, and then we don't touch the other blocks, right? So if we think about it,
so you could just
here,
yeah.
So let's say again we have our 3-block TWAP, and we want the price in the last 2 blocks to just be 1, right? We don't want to manipulate it there, but instead the first price we want to do super high. So I mean, what is that?
That's
we
10,
need to,
or you could put what, 100 or something.
I guess we'd put 6, right? Because 6.
Oh. Yeah, it's, if you just want to.
It'll be 4, right? Because we have 2 already in the other 2 blocks.
Okay, so yeah. 4.
And then divide that by 3, and that will make the price we want.
So right. you would only have to manipulate it in 1 block, and then this arbitrage profit would be less, I guess you could say.
Exactly. So the way that the Uniswap price function works is that it's kind of like parabolic, where the further, like the extremer the price is, the less money it actually takes to move it to even more extreme prices. And so that is why this second option is actually going to be cheaper in terms of the amount of capital required and the arbitrage loss that you're incurring.
Cool.
And yeah, you can also you can do the math for it, or you can just imagine it that like this price function kind of goes up and it gets steeper the further you go. And that means at the end, you don't need as much money when you're already like pretty far up. It just takes a tiny bit to go way further up. That's kind of the intuition to it. Yeah, and so this is what I call in my paper the single block attack, and it is cheaper than the naive attack. And the interesting part about it is that the naive attack actually scales linearly with the length of the TWAP, right? So if you make your TWAP twice as long, then the cost of that naive attack is going to be twice as big, because you have to incur this arbitrage loss twice. Whereas the second attack, there it only scales with the logarithm of the TWAP length. So if you make your TWAP twice as long, then you're only going to have log of 2 increase in the cost. So that means for super long TWAPs, this gets way cheaper. And for small TWAPs, it's similar. For super small TWAPs, it actually turns out that the first one is cheaper.
I think for both of them, right. Also, these are almost theoretical costs to attack, because you're sort of assuming that arbitrageurs are going to be there in the next block as well.
Right. Yeah.
Which is also a fake assumption.
Yeah. So you're assuming that there's going to be perfect arbitrage.
Yes.
And you're assuming that there's an infinitely liquid outside market, right? Because if these arbitrageurs are going to sell into you, they have to get their coins from somewhere, and they have to get that within a single block.
Well, because how would you,
unless they already have it.
Yeah, if somebody went and moved it to 2, how do you know that's not an informed trade and that the price isn't just moving first on Uniswap? Arbitrageurs might want to wait a sec.
Well, I mean, if, for example, this was happening on Uniswap, but not on SushiSwap, then you could actually just do an atomic arbitrage where you buy on SushiSwap and then sell it back on Uniswap without having to hold it for any amount of time.
Right. Yeah.
And also you can take a look at what the other markets are doing, such as Binance and so on. Yeah. And if, for example, you're seeing this prolonged attack in the naive attack, you see that in every single block, the price is getting manipulated again and again, even though it gets pushed down every time. Then you even have time to get extra funds from Binance, for example, right? Because it takes a couple of blocks time to actually do a withdrawal from a centralized exchange.
Yep.
Whereas if you're using another decentralized exchange, such as SushiSwap, let's say, then you can do it instantly.
So actually, having competitors to Uniswap actually makes Uniswap more secure in some ways.
Well, no, because the cost also scales. Well, I mean, kind of, but the cost also scales linearly with the amount of liquidity in the pool.
Sure.
So if, let's say, instead of Uniswap and SushiSwap existing and both being the same size, if Uniswap was just twice as big, it would take twice as much money to manipulate that market. Yeah, but of course, also we're making the assumption of an infinite outside market, which is never going to be completely true.
Right. No, super cool. Yeah, any other attacks or any other things? I mean, I think the one word that I kept reading about Uniswap that maybe you can explain, maybe this is a different thing, but what is cardinality?
I'm not sure what that means, but I can expand further on these attacks if you want.
Yeah, no,
so
it would be great.
Yeah. So now that we have our single block attack, it turns out that this actually makes things super interesting, because if everything just happens in one single block, all of a sudden MEV becomes super important. So basically MEV is like the value of being able to order transactions within a block on a blockchain. And because here in our single block attack, we have just one single transaction, which has a huge amount of arbitrage in it, right? Like selling from 4 down to 1 will make you a lot of money.
Right.
It becomes super important who has the first transaction in the next block.
So this guy right here.
Yeah, exactly. Because whoever is first is going to get all of that arbitrage profit, and whoever is second and trying to do the same thing is going to get nothing, right? Because it's the opportunity is gone. So that means it's super important, or like, if you are able to ensure that you yourself as the attacker are actually going to have the first transaction in that block, then you know that your arbitrage loss is going to be 0, because you're going to arbitrage yourself, right? So you're not going to make a loss. And so either
the attacker would be basically be both of these.
Yes, exactly. So either you can just hope that nobody notices, right? That's probably not going to happen. Or you just make sure that you yourself are actually the person that gets to control the next block, right? So block producers in Ethereum, which are currently miners, and after the merge, that's going to be stakers.
Yep.
They get to decide who has the first transaction. So if you are in the proof of work world, as you are right now, there's not really an easy way to guarantee that you're the next block producer, because it's random who produces the block. But what you can actually do is use a technique known as selfish mining, which means that you mine and you find a block, but then you don't publish it, right? Usually you would publish a block as soon as you found it. But instead, you keep mining, and you mine on top of your own block that nobody else knows about. And what you would do is, in this secret block that you have hidden, you would do this attack and manipulate the market. And then if you happen to find the next block as well, which is unlikely, but it can happen, right? Then in that block, you do the second transaction where you demanipulate the market again. And you only publish these 2 blocks if you actually find the second block. And if you don't find it, then you just let that first block expire. Like, nobody will ever know that you found it. And nobody will be able to see that that transaction would have existed.
Yeah, so this is like a classic reorg attack, right? Like, yeah. So you would have, I guess these are blocks on a chain, and then you come along and you make this block, and somebody else makes this block where the price is still 1, but you say it's 4, and then you would say it's 1 here, but then you would basically push this back in only if you got this one. You would never just publish this one.
Exactly. And only if you were the first person to find that second block, right? So if that block that you drew last in the top one, that one probably wouldn't exist yet.
Yeah, so then you would.
Yeah, so you would do it, it would be like this, and then you publish it, and then your chain is longer than the other one. Yep. And then that makes your chain the canonical chain. And so if you do this, then your arbitrage loss is going to be 0, right? Because you guaranteed that there's going to be no arbitrageurs, because you're the only person that even knows about the transaction. And then that makes this manipulation basically free. We've ignored Uniswap fees so far. That would basically be your only cost, is you have to pay the 0.3% trading fee on Uniswap twice, but that's negligible. And then also you have to pay for the selfish mining, right? So you have an opportunity cost from selfish mining instead of mining normally. And I actually calculated that in my paper. And it turns out that it's actually feasible to do this kind of thing, even if you have very small amounts of hash power. So even if you have, let's say,
we've realized that too. Hash power is so cheap.
yeah, and you don't need a lot of it. So I calculated that if you have 1.5% of Ethereum's hash power, then if you try to do the selfish mining thing for 2 days, you're basically guaranteed to get it. And minting or renting 1.5% of hash power and then doing this strategy instead of mining normally is going to have an opportunity cost of about $150,000. Or at least that's what it was a couple months ago.
Right.
So basically you have like a fixed cost of 150K, and then your Oracle manipulation is free, which probably would cost you like many millions if you did it the naive way.
Yeah.
Yeah.
No, this is
and this is just in proof of work. Like, if you want, I can tell you how it is in proof of stake.
Please tell me. I'm not a proof. I'm very familiar with proof of work and how reorgs work there, but please tell me in proof of stake.
Right. So the big difference in proof of stake is that it is no longer random who produces a block. So here we had to do the selfish mining thing because we didn't know who was going to produce the block.
Right.
But in proof of stake, it's actually assigned ahead of time which validators, which is stakers, get to produce which block in which slot. Like, there's slots every 12 seconds, and those are it's determined up to 12 minutes ahead of time which block is going to be mined by who. So if I'm an attacker there, I can just take a look and see if I have a block in the next 12 minutes. And if not, I don't do anything, right? I just wait. And then at some point I will see, oh, I have a block at some point in the future. And then I can prepare to do this attack, the exact same one. Well, actually, in the first scenario, right here, we said we need 2 blocks in a row. So you can also just wait for that, right? If I also did the math on this, which I don't remember exactly. You can find it on my Twitter. But I think if you have 0.1% of the stake of Ethereum and you just wait, then around every 2 months, you're going to be proposing 2 blocks in a row.
Sure.
And you can just wait for that to happen, which has 0 cost to you, aside from like just normally staking as you would. And so that's not going to cost you a lot. And then after 2 months, you're just going to happen to find 2 blocks in a row, and you're going to know ahead of time, and then you do this attack. And that means you have no cost for selfish mining. And also nobody can say that you like did something wrong, right? It won't even be detectable probably that this happened. You'll look just like a normal validator. And the cool thing is that because you know guaranteed ahead of time, maybe you don't even need 2 blocks in a row. Maybe it's enough to just have 1 block, which is much more likely, of course. Right. And that's because it depends. It depends if you assume that there is a dark pool where you can have your transaction included without it being sent to the public mempool or without it becoming public. Then you can either do the attack in 1 block or like controlling 1 block, which is the first transaction you send to this dark pool and nobody will see it before it's landed on chain. And then as soon as it's landed on chain, everyone knows it's there, but the next block is going to be your block. And then there you can guarantee that you get the first transaction and that nobody can compete with you, right? Like, no matter how much these arbitrageurs are willing to pay, you're just not going to accept it because you are the block producer. And then even if you only control 1 block in proof of stake, which is free and very likely with small stake, you can do this attack. And yeah, you need a dark pool that you trust, such as maybe Flashbots. You know, it's kind of difficult to know if Flashbots transactions ever get leaked. There are people that say that transactions get leaked every now and then. It's very difficult to prove. So yeah, it depends on if you trust something like that, but then you can do this attack for like free with no costs. You do need the capital though, right? You can still not use this flash loan. So you'll need enough to actually manipulate the market to this high price that you've decided on.
Cool. So basically what you're saying throughout all this is Uniswap oracles are manipulable.
Right.
General word. So, like, I guess unless there's more that you want to go over, like what can be done to kind of solve this for the oracle user? Because like part of the beauty of a Uniswap oracle versus say a Chainlink or a Teller is that you actually have a price every block. You don't have to wait, you don't have to pay gas to put a price on chain. You can actually read a semi up-to-date price, and as long as no one's manipulating it, it's pretty good. It can be much faster than Chainlink or an off-chain oracle.
Yeah. So for this specific attack that I've discussed now, it actually turns out that in Uniswap v3 they accidentally fixed it without even knowing about it.
Which one? The proof of stake one? And
well, just anything that uses the single block attack, which was the proof of stake, the proof of work, everything. And the reason why is that in Uniswap v2 they use what's known as the arithmetic mean, which is just an average, right? As we discussed, you just take the sum and then you divide by the amount of entries. Whereas in Uniswap v3 they use the geometric mean, which is a little bit different. So maybe we want to make an example with just 3 numbers.
Well, here we have 4 one-on-one.
Yeah, exactly. So what you do to get the geometric mean is you multiply them together. So it would be 4 times 1 times 1. And then you take the nth root, where n is the number of things you have. So the third root here.
Which is something like that.
Which is also equivalent to 4 to the power of 1/3. Which maybe if I can find that in my calculator here.
Yeah. Let's see exact, what do we get here? 1. Torgin's point.
Math is difficult, huh?
So in the single block, the price would be for the arithmetic mean, it would be 4. It would be you just add them. 4 plus 1. 1 equals 6 divided by 3 equals 2.
Yeah.
However, in the other one is
that one is 1.58.
1.58. All right. So yeah, so it would be significantly more costly using this way, right?
Exactly, because basically, because you have that root in there, it means that single outliers matter a lot less for geometric mean than arithmetic mean. So if you just have like one huge value, as we have here, and then small values next to it, then the geometric mean doesn't react as much to it. So if you wanted to attack that, you would probably have to attack multiple blocks within the TWAP period and not just one.
Yeah, so you would have to do this for multiple blocks, I guess you could say.
Right. Yeah.
Very nice.
Yeah, and that's like the most significant change in the V3. I guess maybe for completeness, we can also mention that in V3, they actually added a super nice feature, which is that you can have multiple accumulator values stored inside the Uniswap contract. So we said before that in V2, the user has to store these themselves, right? Whereas in V3, there's actually an array which is kind of used as like a circular buffer. So like you write things into it, and then if it's full, you just start at the beginning again. And every single block, that buffer is just filled up. And so that means whatever the length is of the buffer, you can go that many blocks back and see what the accumulator value at that point was. And that buffer starts at just the size of 1. So you can only see the 1 price, but then anyone can pay to expand that, which is going to cost you gas on Ethereum, of course. And you can expand it up to a length of like 9 days, something like that. And so then that would mean if you do that, you can just go look in the contract, like what was the price or the accumulator value 6 days ago, and then use the thing now, and then you can use the 6-day average, or you can look up any historical values, which is nice because in V2, like once a thing has passed, you can never find it again, right? Because it doesn't get permanently stored.
Nice. All right. Any other best practices you can talk about whenever you're using uni oracles? What else can we do? So obviously, like if you want to use a Uniswap oracle, that part of the problem with people could use, say, a 30-minute TWAP oracle, but now your price is 30 minutes old. So how do you there's obviously negatives to having a 30-minute old price or even an hour old price.
Right.
What would you do to sort of fix some of these issues?
Yeah, so there's basically a trade-off in the length, as you mentioned. The longer you make it, the harder it is to manipulate, but the more delayed it is. There's the other thing, which is also a factor, is the liquidity, right? If you just double the amount of liquidity in this Uniswap pool, then it becomes twice as hard to manipulate, and there's no downsides to do that. So just increasing the amount of liquidity is actually already, sorry?
Minus the cost of getting liquidity.
Right, of course. Yeah, so that's actually something that, for example, the Euler protocol has done. They use Uniswap v3 oracles for their lending protocol, and they've made deals with market makers to actually increase liquidity on Uniswap v3 by depositing the market maker's money in it, with the express goal to strengthen these oracles and make them harder to manipulate. And that's really the most important thing, is just use assets that have good liquidity, right? Like an ETH USD pair, for example, is super hard to manipulate because there's tons of liquidity in it. Whereas if you use some random coin that nobody cares about, it'll get manipulated super easily, and maybe there won't even be any arbitrageurs out there to bring the price down, right? And also maybe there's not another market, right? We also made this assumption that there's another market somewhere with infinite liquidity that can be arbitraged with, and for small coins that's often not the case.
Yeah, this is the only oracle for a lot of, I know.
Exactly.
It makes it hard.
So there was actually one example pretty recently with inverse finance, and they fucked up everything basically. So they used their own token, the inverse finance token, which is a small illiquid token. They allowed that as collateral, which is already just a bad idea, to use an illiquid token as collateral. And then also they used the Uniswap, or SushiSwap technically, which is the same thing, V2 oracle, but they didn't use the provided reference implementation of the TWAP where you provide your TWAP window. But instead, they just used the most recent price, which was the Uniswap v1 thing. So basically, they only took one block's price, and their TWAP length was over 1. And then that made it way easier to manipulate even. So yeah, that's a pretty recent, I think a couple months old example of using these oracles incorrectly. But yeah, I would say if you use super liquid coins, like an ETH USD pair, on Uniswap v3. On Uniswap v3, there's also this little nuance that liquidity is not equal at all price ranges, right? On Uniswap v3, you could, for example, have liquidity just around your current price. And then maybe if you go past the edge of that, all of a sudden there's almost no liquidity. And then there, it becomes super easy to just manipulate the price way high. So on V3, it's kind of important to have full range liquidity, or at least wide enough liquidity for that reason. Yeah, and then it can work, which, as we've seen with Euler, right? They've operated using Uniswap v3 oracles for a couple months. They have pretty decent TVL. They haven't gotten wrecked yet. I mean, who knows?
Well, I know the one, so we had talked to, so one of the users of Teller is Liquidity.
Mhm.
They're a stable coin, and one of the reasons that we asked them, and like, why didn't you use a Uniswap Oracle? And part of the reason is whenever they were launching, Uniswap v3 had not launched yet. So they were still in Uniswap v2, and then all of the liquidity moved from Uniswap v2 to v3. So the Oracle address would have changed, which is something that users may have to sort of accept, that, eventually Uniswap might upgrade again and change the address, and the liquidity may move. So you'll have to sort of figure that out on your.
I mean, you have that same problem with any other Oracle as well, right? Like, for example, the Chainlink oracles can also update. So I think what you could do is kind of put a proxy in between.
Yep.
Where you can direct it to different versions, where of course you're introducing another point of failure. Maybe at that point you actually do want to just use an off-chain oracle instead, because if you're okay with that point of failure, you're probably okay with the other one as well.
Yeah.
I mean, that's kind of, to me, the biggest downside of things like Chainlink. I'm not too familiar with the details of Teller, how you guys do it, but in Chainlink, they've built this like huge protocol for decentralized oracles, but at the very bottom of it is just a proxy contract that's upgradable, where they can replace the entire implementation with a multi-sig. And so basically everything that you built on top of it in the implementation doesn't matter, because you can just replace it in the proxy with whoever has the rights to upgradability for that. So like, that's also one thing that you avoid, of course, if you use a fully on-chain oracle like this. And then I guess just hope that there's liquidity for as long as you need it.
Yeah, I mean, as far as the decentralized oracle goes, it's about as decentralized as you can get, which is really, really good.
Right.
So completely immutable. You may have to provide your own liquidity for the thing, but it works.
Exactly.
This was great. I guess to wrap up, any final parting words for Uniswap oracles or users of this?
Yeah, I mean, just make sure that you know what you're doing. I think there's a lot of easy ways to screw up. It is like the way to get a fully decentralized oracle. So if that's what you need, this is it. I mean, otherwise, try to build something that doesn't use an oracle, or be okay with whatever trust assumptions you need to make for other oracles.
Well, I like Taylor, but
yeah,
I'm partial. We can.
I understand that.
No, this was great though.
Yeah.
Thank you so much for kind of walking us through. And then where can people find you? Do you want people to find you?
Yeah, sure. Best place is Twitter. My Twitter is @mtorgin. I post about like sometimes Oracle related stuff, sometimes like general crypto stuff, sometimes security stuff, sometimes
it's pretty good.
Stupid stuff.
Yeah, and we'll post a link to chain security and then your paper as well.
Yeah, sounds great.
Super cool. Thank you so much for coming on. We'll see.
All right, thanks for having me.